Earth has always held monsters, not the imagined creatures of legends, but the real rulers of their age. They moved through seas and swamps, deserts and skies, carrying weapons that seemed designed for nightmares. Their forms were not accidents, but solutions to problems set by ancient climates and ancient food webs. Fossils keep their records with patient clarity, revealing armor plates, outsized jaws, and wings that measured greater than human doorways. When these bones first emerged from stone, even seasoned scientists hesitated, because the shapes seemed to deny ordinary rules. Yet each strange design carried a logic that fit the world that built it. The ancient ocean could turn a fish into a living battering ram. The riverbank could grow a reptile into a living trap with a skull built for ambush. The sky, when its air was heavy and forgiving, could lift bodies that appear impossible today. To call them monsters is to admit the awe they still command. To call them real is to honor the work of stone, time, and careful hands. Their stories begin in darkness and pressure, where layers of mud became pages and pages became books. Those books waited for readers who could recognize truth written in unfamiliar letters. This is a guided walk through that library, where every shelf contains a creature that seems unbelievable until you see the logic of its life. What follows is not fantasy, but a careful account of power shaped by place and time. The ancient seas bred some of the strangest and most fearsome bodies ever to swim. Picture a coastline in the Devonian, with reefs growing like stone gardens and armored fish cruising along their edges. Among them moved Dunkleosteus, a giant with a head sheathed in thick, bony plates. It did not wear teeth in the usual sense, but sharpened its armor into cutting blades where jaws met. When those blades snapped shut, they delivered force measured by modern experiments as truly crushing. Shells that once protected prey could be split by that single motion. The skull worked as a hinge and a guillotine, built to turn bone and shell into dinner. Dunkleosteus ruled not by speed alone, but by the confidence of armor and the certainty of its bite. It patrolled ancient coastlines where sunlight fell into clear blue, and every ripple could mean a meal. Even today, the fossil head carries a presence that startles museum halls. Nearby, in deeper time, waters swam Anomalocaris, a predator from Cambrian seas that confused science for decades. Its parts were first cataloged as separate animals, a ring of plates mistaken for a jelly, and a grasping appendage named like a shrimp. Only later did the full animal appear, with rippling side flaps for swimming and spined arms held out to seize soft prey. Its mouth was a rotating circle of plates that closed like a camera's iris on whatever it held. In those early oceans, these bodies made sense because prey were soft, and speed with precision meant everything. Land offered its own stage for monsters, and rivers wrote the most dramatic scenes. Imagine a broad tropical channel with sandbars, backwater pools, and shade cast by conifers and ferns. Along that edge waited Sarcosuchus, a crocodile relative scaled far beyond modern giants. Its skull stretched long and heavy, its armor thick, and its body rolled forward with the slow confidence of an animal that knows patience is a weapon. A step too close to the bank could turn an ordinary day into a struggle against a mouth built to hold. This was not a creature of luck, but of timing, reading currents and light and the paths of the unwary. In nearby forests stretched Arthropleura, a millipede relative that measured longer than a small car. It moved like a living staircase of armored plates, passing through leaf litter that barely rustled when it traveled. Its size belonged to a world rich in oxygen and rich in plants, where the ground itself seemed to feed motion. The sight of such a body crossing a path would erase any notion that only vertebrates could command fear. Land in these ages was not a safe alternative to sea, but another arena where size and design explored extremes. Every hillside, every clearing near water, every fallen trunk offered places for ambush and escape. The monsters of land were not only large, they were perfectly fitted to their chosen theaters. They succeeded for millions of years because the script of their world matched the shape of their bodies exactly. The sky belonged to monsters for a time as well, and their silhouettes would have remade our sense of scale. In late Cretaceous era, Quetzalcoatlus rose from floodplains and cliff edges with wings that spanned the width of a small plain. On the ground, it stood as tall as a giraffe, a strange, stilted figure crowned by a long, toothless beak. Its bones were thin and strong, supported by internal struts like a masterpiece of natural engineering. Flight came from a combination of wingspan, lightweight bones, and a powerful launch, an athlete's vault into wind that caught and held. The creature was not a myth, but a master of thermal currents and long-distance travel. It scanned rivers for carcasses, searched beaches for food, and moved across landscapes with a reach that no land predator could match. Far earlier, when air held more oxygen and was kinder to unusual sizes, Meganeura hunted like a bird of prey built from glass and wire. This dragonfly relative wore wings wider than a human arm span and controlled them with precise strokes. It patrolled canopy lanes as a silent ruler, turning midair with a skill modern flyers still echo. Over swamps heavy with fern and club moss, its shadow meant that the space above water was claimed. These sky monsters were not accidents. They grew from the physics of air and the opportunities of open niches. When conditions shifted, their lines faded, but the blueprint of flight left its marks on every modern wing beat. At first discovery, many of these monsters seemed to break rules. Scientists argued about whether insects that large could truly fly, and whether a crocodile relative could reach such size on prey from rivers alone. Fossils forced those debates into careful work. Air density, oxygen levels, and wing loading are not guesses, but problems with measurable answers. Bones record weight and forces in their thickness and their inner architecture. Teeth and jaws record diet not only by shape, but by the microscopic wear left from meals. In labs, engineers build models and run air through wind tunnels to see if wings hold and how they stall. Paleontologists compare sediments and isotopes to understand where bodies lived and what conditions surrounded them. Mistakes are folded back into the record and corrected as new specimens appear. The mouth of Anomalocaris moved from confusion to clarity as complete fossils were prepared. The jaw blades of Dunkleosteus went from fearsome legend to measured bite force with modern testing. The launch and glide of Quetzalcoatlus shifted from fantasy to environments where thermals and cliffs make sense of its plan. Each step turned the unbelievable into the merely extraordinary. Each correction made the story stronger, because it anchored wonder to evidence and evidence to method. Science learned not to dismiss the improbable when stone says otherwise. It learned to widen the map of what life can do when given time and a new stage. The legacy of these monsters reaches beyond awe into lessons about possibility and change. They remind us that environments write the rules and bodies read them. When air grows rich, wings can grow bold. When rivers lace through continents, ambush waits where water turns shallow. When seas bloom with soft-bodied prey, armor and cutting plates rise as answers. Their reigns ended not because monsters fail, but because worlds turn and scripts change. New climates asked different questions and different bodies answered them. Some designs left echoes that still fly at dusk or wait below riverbanks for careless steps. Others vanished completely, leaving only stone pages and our guesses sharpened by new tools. To study them is to learn humility, because the planet's imagination exceeds our first explanations. It is also to learn hope, because life fills empty spaces with experiments that often succeed in ways we could not predict. The next canyon wall or coastal cliff might hold a body plan that resets another rule. The next carefully brushed fossil might push us to redraw the lines again. Until then, the monsters that once seemed unreal keep their watch in museums and in field notes, patient as stone, honest as bone. They were real, they were powerful, and they were exactly what their worlds required. If they ask anything of us now, it is to keep our minds wide and our questions generous, because the record of life is still being written beneath our feet.